In this video, we'd like to give you a brief description of the electrical system. The Kustodian ION runs off of a 24-volt DC system, and that power is supplied by two 12-volt batteries that are located underneath your charger and converter, which we will talk about in a little bit. On the 7-pin side of the machine, you have your CPM2A microprocessor, and you have a series of different relays that are explained in depth in your troubleshooting manual supplied with the machine that will control different high voltage functions. We also have independent fusing for all of the main power sources and an amp gauge so you can monitor how much amp draw is happening to the machine, for example, when the vacuum motor is running. Directly underneath the charger, when we remove the 4 Phillips head screws that are in each corner, you will find the 2 dry cell batteries that power the Kustodian ION. This technology is not like your typical battery technology. This is a leak-free, non-memory holding battery, which means that, like most conventional batteries, as we continue to charge them up, they start to lose life or only hold half or a small percentage of power. These batteries, for example, if you run them down 50% and recharge them back up 50 more percent, you're not going to get a 50% charge. It will hold the whole 100%. It takes about 3 to 4 hours to go from 0 to 100%, or about 50 minutes to go from 0 to 95%. So typically every day when you're done with the machine, you'll want to plug it in, let it charge overnight. Once it's done charging, it will stop. It will not continue to charge the batteries or possibly destroy any of the lead or the compounds that are inside of them. And they both weigh 26 pounds apiece. These batteries, based on a 40-lane center, should get about 400 cycles. If you had a 24-lane center, you'd get about twice that much. The charger converter that is supplied with a Kustodian ION gives you the best of both worlds. You have the ability to run strictly off of the two 12-volt batteries, or if someone forgot to charge them or they possibly failed in the future, you have the option to use the 125-foot power cord that is supplied with the lane machine as a backup. You also have a voltage regulator that is located underneath the PLC plate right directly to the left of your second battery. That is going to ensure that the same voltage remains at constant anytime this machine is running. When there's a small deviation in that voltage, it is going to shut the system completely down. This will provide you consistent lane conditions across the house. Older conventional battery technology machines did not have that. So as the battery power decreased, so did the RPM of the buffer speed, the vacuum motor, and some of the other vital functions. To the right of the fuse bank, as we described a little bit earlier in the video, you will notice that there is an amp gauge. This allows the operator to monitor the current power status of the 2 batteries located underneath. For example, when the vacuum motor is engaged, as we will do with this relay and this test button on top, you'll see how much amp draw is being taken by the machine. You'll notice that you have 2 small lights on the 7-pin side plate of the lane machine. One is a green light and one is a red light. When the power cord is plugged into the outlet to recharge the battery and the red emergency stop switch is depressed, the red light will be on. When the machine is running strictly on battery power without a cord, you will see that the green light will be lit up.